Reciprocating compressors are the most widely used of all compression equipment and also provide the widest range of sizes and types. Ratings vary from fractions to more than 20,000 horsepower per unit. Pressures range from low vacuum at intake to 65,000 psi or higher. For example, for a typical industrial plant air service, they are used up to 3,000 horsepower and in pressure ranges from low vacuum to 500 psi. The reciprocating compressor is classified as a constant volume, variable pressure machine. Why is that? Because since it increases the pressure of the gas by operating on the gas in a confined space, then a reciprocating compressor will always increase the pressure, provided sufficient power is available, and the compressor is designed to meet this objective. For this reason, a reciprocating compressor will be insensitive to gas composition changes and to system resistance changes. And this is a very important thing to remember. So keep in mind, reciprocating compressors will operate at the same delivered volume flow regardless of system resistance or gas composition. This point is so important that we will get back to it further ahead. Now, for most applications, reciprocating compressors are the most efficient built today. They can be fitted with capacity control devices to closely maintain their efficiency at partial loads. They can be built to handle almost any commercial gas, provided corrosion problems in some extreme cases can be solved. Gas cylinders are in general lubricated, although a non-lubricated design is also available. Now, because of the reciprocating pistons and other parts, as well as some unbalanced rotating parts, inertia forces are set up that tend to shake the unit. It is therefore necessary to provide a mounting that will stabilize the installation. The extent of this requirement strongly depends on the type and size of compressor being involved. So, these machines are normally designed to be installed in a building but can be fitted for outdoor installation. Now, another important fact about reciprocating compressors is that they should be supplied with clean gas, and so inlet filters are highly recommended. An additional point to remember and to keep in mind is that these machines cannot handle liquids that may be entrained in the gas. Why is that? Because first, liquids are incompressible fluids, and second, liquids tend to destroy lubrication and cause excessive wear. Finally, one last characteristic is that reciprocating compressors deliver a pulsating flow of gas. This is sometimes a disadvantage, but pulsation dampeners can usually eliminate the problem. The pulsation control of reciprocating compressors and the design of dampeners will be covered in detail further ahead. Manufacturers design reciprocating compressors to match the exact need of the user. These compressors fall into two general groups: moderate duty machines and heavy duty machines. Moderate duty compressors are designed for reliable operation over a reasonable service life, but should not be installed where continuous full load, long time operation is required. This does not mean that these units will not operate for long full load periods. It does only mean that maintenance cost will be greater than normal. In general, moderate duty compressors are of single-acting cylinder design. Usually, these compressors are air-cooled. However, they are also offered as water-cooled designs in horsepower ranges of 30 to 125. They are built as single-stage units for pressure ratings up to 50 psi and as two-stage units up to 250 psi. Now, for a reciprocating compressor to be considered heavy-duty, it must be both water-cooled and double-acting. Recall, we have seen that whenever gas is compressed, heat is generated. So, proper cooling of the internal parts of the compressor in order to maintain the coolest possible temperatures at critical points is a basic part of the design. In the case of the water-cooled reciprocating compressor, the cylinders and the cylinder heads are surrounded by water jackets, and the heat transfers through the metal to the water much more efficiently than heat transfer through the metal to air. Water-cooled reciprocating units handle cooling more efficiently than comparable air-cooled units. This allows for continuous duty with low maintenance. The heavy-duty water-cooled reciprocating compressor has a relatively slow rotative speed, between 180 to 900 RPM. These machines are designed for long service life at low maintenance cost. So it is not unusual for this type of machine to be in operation even for 50 years after installation. Because they are conservatively designed with water-cooled cylinders, they are heavier, more expensive to manufacture, and more expensive to install than the other types of compressors. They are also the most efficient of all compressors on a brake horsepower capacity basis, particularly at part loads, due to their ability to be controlled effectively at part loads. We will see in detail how the capacity of these compressors is controlled in a later section. The reciprocating compressor uses automatic spring-loaded valves, as the ones you can see here, that open only when the proper differential pressure exists across the valve. This was discussed in a previous video, but is reminded here using the following simplified 3D animation depicting a double-acting cylinder. So, keep in mind, inlet valves open when the pressure in the cylinder is slightly below the intake pressure, while discharge valves open only when the pressure in the cylinder is slightly above the discharge pressure. As we have learned so far, compressors are machines designed for compressing air or other gases from an initial intake pressure to a higher discharge pressure. In this video, I will introduce you to some useful terminology regarding reciprocating compressors. First, keep in mind reciprocating compressors, as the one depicted here, are those in which each compressing element consists of a piston moving back and forth in a cylinder. Single-acting reciprocating compressors are those in which compression takes place on one side of the piston, usually on the side away from the crankshaft. Double-acting reciprocating compressors are those in which compression takes place on both sides of the piston, with intake and discharge valves at both ends of the cylinder. Single-stage reciprocating compressors are those in which compression from initial to final pressure is completed in a single step or stage. On the other hand, multi-stage reciprocating compressors are those in which compression from initial to final pressure is completed in two or more distinct steps or stages. Intercoolers are devices for removing the heat of compression of the gas between consecutive stages of multi-stage compressors. Aftercoolers are devices for removing the heat of compression from the gas after the last stage of compression is completed. Keep in mind, aftercoolers are one of the most effective means of removing the major amount of moisture from the air, provided they have the capability of cooling the air down to less than 100 degrees Fahrenheit. Moisture separators are devices for removing moisture precipitated from gas during the cooling process, allowing the condensate to collect and then drain via either a manual or an automatic condensate trap. Finally, air receivers are pressure vessels that must be built in accordance with the Code of American Standard of Mechanical Engineers. Air receivers take the discharge of the compressor, piped into them, for the purpose of storing the air and simultaneously reducing the rate of pressure fluctuation in the air system. This will reduce the frequency at which the compressor will either load or unload or start and stop, as the case may be. We will see this in detail in the pulsation control section.